This video will talk you through how to use the unit circle to find exact trig values. The assumption is that you either have access to or can draw from memory an entire unit circle, that you're able to label all the degrees and radians that you see in this picture from 0 to 360, including the quadrantal angles, and that you're able to give all of the x and y coordinate values for each of the points that you see going around the unit circle. So what I'm going to do is talk you through a series of questions like you would find on the test that you'll be taking. And they basically ask you to find a trig function of an angle. The angle can be given in degrees or radians, and it can be an angle between 0 and 360, or it could be an angle bigger than 360, or it could be a negative angle. You'll notice that on this first page, all of the questions are sine and cosine. And what I'll do is then on the next page, give you some problems that are secant and cosecant, then some problems that are tangent and cotangent. And on the third page, then I'll mix everything up so that you can see my process for deciding what method to use where. Now you'll need to remember as you go into this that all of the x values that you see for each point represent a cosine, and all the y values that you see represent sine. And so for these 6 problems over here, you merely need to find the angle, and each of these angles is an angle between 0 and 360 or 0 and 2 pi. And you just need to find where that angle is on the unit circle and decide if you're looking for the x value or the y value based on cosine or sine, and that's your answer. So for example, cosine of 135, I'm going to find where the 135 angle is on the unit circle. I'm going to look at these x and y values. Cosine is the x value. And so I am going to isolate the x value there, and that is straight up the answer to cosine of 135. Next, I will look at the sine of 240, and I find 240 on my unit circle. That's this angle here. Sine is my y values, so I'm going to look at that y value, negative radical 3 over 2, and that's going to be the sine of 240. Now, the same thing works for the quadrantal angles. When I say quadrantal angles, I mean 0, 90, 180, 270, and 360. You could think of them as multiples of 90, or you could think of them as the angles that fall on the x-axis or the y-axis. And 90 is the positive y-axis up here. And again, your cosine is the x value. And so I'm going to look at that 0, and that's going to be my cosine of 90. Similarly, for sine of 270, 270 is a quadrantal angle. It's the negative y-axis. And sine is your y values. So your -1 will be the sine of 270. Now nothing changes when you're looking at radians instead of degrees. 5 pi over 3 is less than 2 pi, so I can find that angle on the unit circle. I'm asking you for cosine. Cosine is your x values. And so in this case, cosine of 5 pi over 3 is positive 1/2. And likewise, sine of pi over 3, find that pi over 3, that angle is right here. Sine is your y values, and so sine of pi over 3 is going to be that positive radical 3 over 2. Now, on the other side of the page, over here, you have problems that will require just a little bit more computation in order to start them. You still need to find the angle, but notice that 510 and 675 are numbers that are bigger than 360. And so for those two problems, you're going to want to subtract 360 to find the coterminal angle. So 510 minus 360 is 11 minus 6 is 5, 4 minus 3 is 1. So 150 degrees. I'll also do 675 while I'm up here subtracting. 675 minus 360, 5 minus 0, 7 minus 6, 6 minus 3 is 315. So you can say that sine of 510 is going to equal the same thing as sine of 150 degrees. And cosine of 675 is going to be equal to the same thing as cosine of 315 degrees. So sine of 150, here's 150, sine is your y value, so sine of 150 will be 1/2. And cosine of 315 degrees, 315 is right here. Cosine are your x values, so that's going to be positive radical 2 over 2. Again, you use the same thinking if you've got radians. In this case, you know that 13 pi over 4 is greater than 2 pi because 2 pi would need to be rewritten as something over 4. So what I would do here is I would multiply 2 pi over 1 times 4 over 4 so that I have those common denominators, and you get 8 pi over 4. And 13 pi over 4 is greater than 8 pi over 4. And so then you would subtract 13 pi over 4 minus 8 pi over 4 to get 5 pi over 4. And so sine of 13 pi over 4 should equal the same thing as sine of 5 pi over 4. Five pi over 4 is right here in the third quadrant. Sine is your y values, and so the answer here would be negative radical 2 over 2. So those three problems that I just did dealt with angles that are greater than one full rotation, either in degrees greater than 360 or in radians greater than 2 pi. But for these next three problems, these all deal with negative angles. And so you need to understand that negative angles rotate clockwise, which is the opposite direction of what you're used to. So when I say clockwise, I mean you start at 0 and you rotate in the direction of clock, whereas we have been starting at 0 and rotating this way counterclockwise. Our negative angles are going to rotate clockwise. And so if I'm thinking about 4 pi over 3, what I can do is I can look at just the pi over 3s, and I can say something like, okay, if this is 1 pi over 3, this is 2 pi over 3. This is 3 pi over 3. Here's your negative 4 pi over 3. So the angle negative 4 pi over 3 would be right here. The other way that you could do this is you could add negative 4 pi over 3 plus 2 pi. So negative 4 pi over 3 plus 2 pi would get you a positive angle, but you'd have to change 2 pi to something over 3, and so you would multiply here by 3 so that you have common denominators. So now you have negative 4 pi over 3 plus 6 pi over 3. Negative 4 plus 6 pi is positive 2 pi over 3, which gets us back to where we were, 2 pi over 3. So you can either look at it as I know how to find the negative angle, or I can add 2 pi to get the coterminal angle. But either way, what you're looking for is the x and y values at this point right here, and that's going to be the cosine is the x value, so that's going to be your negative 1/2. For the next one, negative 390 is more than one full negative rotation. And so you would start at 0, you would start here at 0, go one full rotation, and then you're going to need to go past that. So again, like I've said in class, you can use your intuition and say, look, I know that this is negative 360, and then another 30 would be negative 30, and that's right here. Or you can do what I've been writing in green here and just keep adding 360 until you get an angle that is between 0 and 360. So you could say negative 390 plus 360 is negative 30, and then you'd have to add again, negative 30 plus 360 is 330, but either way that gets you to that same place right here, that angle. And so you're going to look at this point and the x and y values. Your y value is your sine, and sine of 330 is going to be negative 1/2. And so your answer for sine of negative 390 is also going to be negative 1/2. And for this last problem, similarly, I see that negative 17 pi over 6 is more than one full negative rotation, because negative 12 pi over 6 is one full rotation. So you can say, okay, negative 17 pi over 6 plus 2 pi is the same as negative 17 pi over 6 plus 12 pi over 6. Miss A, where did you get 12 pi over 6? Because I said 2 pi over 1 times 6, because I need common denominators. And then negative 12 pi, or negative 17 pi plus 12 pi is negative 5 pi over 6. And then again, you need to add negative 5 pi over 6 plus 12 pi over 6. Just keep adding 2 pi, or 12 pi over 6, and you get 7 pi over 6. And so again, either way, you can say, look, I know that a negative angle goes in this direction. This is 12 pi over 6, and then 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Another 5 pi over 6 gets me to here. That's one way of doing this. Or you can do what I just did in green and repetitively add 2 pi, which is the same as 12 pi over 6, and get to a positive angle or a negative angle that you are better at drawing. But either way, you're looking specifically at this point right here, and you're saying, okay, I know that cosine is the x value of these points, and so cosine is going to be negative radical 3 over 2. Now on the next screen, then I will be looking at secant and cosecant first, and then tangent and cotangent next. So let's start on the left-hand side of the page here, the problems that are all dealing with secant and cosecant. And remember that cosecant of an angle is equal to 1 over sine of that angle. And remember that that just means the reciprocal of sine. And similarly, secant of an angle equals 1 over cosine of the angle. And again, that just means take the reciprocal of cosine. So when I look at these 6 problems here, literally what I'm going to do is for the secants, I'm going to find the cosines of the given angles. And for the cosecants, I'm going to find the sines of the given angles. And then I'm just going to write each one as a reciprocal. Of course, I started with a hard one. Why did I do that? I should have not started with 225, but we can jump right in. So let me start by just highlighting the ones that are secant. I have to move that screen a little bit. I'm going to highlight green so that you can look for the green that is going to be the reciprocal of cosine. And my thinking here for each of these is find the cosine of the angle and then take the reciprocal of that. So I use the method I used on the previous page. I'm not going to walk you through that again, but cosine of 225 is negative radical 2 over 2. Cosine of 180 is negative 1. And cosine of negative 5 pi over 3 is positive 1/2. And I'm going to take each of those fractions and I'm going to flip them. Let's actually come back to secant of 225 after I've done the other two. So for secant of 180, what you're thinking here is that that's going to be 1 over whatever the cosine is. And so 1 over negative 1. And then just think, what's 1 divided by negative 1? That's going to equal negative 1. So the secant of 180 is also negative 1. And I'll do the same thing here for 5 pi over 3. And you can either think 1 over 1/2, which is kind of gross, or you can just flip the 1/2 becomes 2 over 1. And so the secant of negative 5 pi over 3 is just positive 2. So now the radical 2 over 2 is a little bit more confusing. You could, let me say, don't do this. Don't do this. Don't flip radical 2 over 2. And can I start with, if the number that you're flipping is negative, your answer is going to be negative. So we know that our answer to secant 225 is going to be negative. It's an angle in the third quadrant. Secant is negative in the third quadrant. That's your all sad turtles cry. And so let's just set the negative and talk about the flipping. If you flip radical 2 over 2, then you get 2 over radical 2, and then you have to rationalize the denominator, which is weird, and then you get 2 radical 2 over just 2, and then you have to cancel the 2's, and that whole thing equals just radical 2, gross. But instead, let me find a different color for this instead part. So instead, instead, remember that where we got radical 2 over 2 from was when we first did the triangles that were the equilateral and isosceles triangles to derive all the 30, 45, and 60 degree angles. We said that for the 45 degree angles, cosine and sine were 1 over radical 2, and that's where we got the radical 2 over 2 from. And so flip 1 over radical 2, and that gets you just radical 2 over 1, or just radical 2. So that's going to be your answer for secant of 225 is negative radical 2. Next, let's take a look at the cosecants, and I will highlight those purple so that you can see them visually different from the secants. And again, what I want to do first is decide what is the sine of each of those angles, and then I will take the sine and find the reciprocal of it, or 1 over sine, to find the cosecant. So like I did last time, I'm not going to take the time to explain each of these to you, but real quick, sine of 5 pi over 6, here's 5 pi over 6, the y value is 1/2. Next one, sine of 2 pi. 2 pi is 1 full revolution. It's not labeled on this unit circle, but I would like you to do so when you draw the one that I am going to ask you to do. But anyway, 2 pi should be the same as 0. That's a coterminal angle, and sine is your y value, so sine of 2 pi is 0. And finally, sine of 600. Well, 600 minus 360 is 240, so you're going to place that 600 degree angle right here, and sine is your y value, so that's going to be negative radical 3 over 2. So let's start with the sine of 5 pi over 6. So your sine of 5 pi over 6 equals 1 over 2. And remember that you're then going to just flip that so that it becomes the reciprocal. So you can flip 1 over 2 and get 2 over 1. And so straightforward positive 2 is going to be the value for cosecant of 5 pi over 6. That's fairly straightforward. With sine of 2 pi, that's not a fraction to flip. So sine of 2 pi is 0. If I want to consider the reciprocal is going to be 1 over 0. And as soon as you see 0 in a denominator, remember that you can't have 0 denominators, so that's going to be like your little red flag there, that the cosecant of 2 pi is going to be undefined. And you can just think of it like anywhere sine is 0, cosecant is undefined. Likewise, anywhere secant is, or anywhere cosine is 0, secant is undefined. And then your sine of 600 is negative radical 3 over 2. This one's going to take just a little bit more work. So you want to flip negative radical 3 over 2, which will get you negative 2 over radical 3. Then you have to rationalize the denominator, so you multiply by radical 3 in the top and the bottom, and you end up with negative 2 radical 3 over just 3, and that's going to be your answer to cosecant of 600. So, I thought I was using my ninja mode this whole time. Literally, both pages so far, all the zooming in and out, I thought you weren't going to see. I'm so sorry. So now I've got my ninja mode straight. Now you shouldn't see all the zooming in and out. My apologies. So let's look at the other side of this page, all the tangents and cotangents. And the thing that you want to remember for your tangent and cotangent is that your tangent is going to always equal sine divided by cos. In other words, your y value divided by your x value. And because cotangent is the reciprocal of tangent, cotangent is going to equal cos divided by sine. In other words, your x values divided by your y values. And so what I'm going to do to compute all of these tangents and cotangents is look at my x and y values of the points. So let's start with making sure that we can find all these angles. And I'm gonna fill those in. You might want to pause the video, but what I'm going to do is I'm going to go through all 6 of these angles and just write your x and y values here, but I'm going to not record me doing that. Remember that 420 is bigger than 360, so you'll need to subtract 360. Negative 8 pi over 3 is more than 1 full negative rotation, and so you'll also need to take those 2 things into consideration. So what I think I'll do, like I did on the other side of the page, is I think I'll start by highlighting the tangents. Let's make tangents yellow, and then let's make cotangents, how about blue? So cotangents can be blue, so that you can visually isolate. And remember that we're going to take the points that I found, the x and y values, and make fractions out of those based on whether we're talking about sine over cos, y over x, or cos over sine, x over y. So tangent is going to be y over x, and so that's going to be 1/2 divided by negative radical 3 over 2. Then I can cancel the 2's because they're the same. When you have a fraction over a fraction and the denominators are exactly the same, you can cancel the denominators. Be careful that you never can do that with numerators, only with denominators. You get negative 1 over radical 3, rationalize your denominator, and you get negative radical 3 in the numerator over just 3 in the denominator. So tangent of 150 is going to be negative radical 3 over 3. For cotangent of 7 pi over 4, you're going to do the opposite, so x over y. So you're going to do radical 2 over 2 over negative radical 2 over 2. Again, cancel your denominators because they're the same. And that gives you negative radical 2 over radical 2. Uh-oh, I should have seen at the beginning that I've got something over the same number but negative, and that whole thing just equals negative 1. And so cotangent 7 pi over 4 equals negative 1. Tangent is going to be y over x. So 1 over 0. Here's your 0 denominator again. And so as soon as you see 0 in the denominator, you're done. And that trig value is undefined. Cotangent is going to be your x over your y. And so that's going to be 0 over negative 1. 0 in the numerator is fine, and it just equals 0. So cotangent of 270 is just 0. For tangent, it's y over x. So I'm going to have radical 3 over 2 over 1 over 2. Cancel your 2's, and you get radical 3 over 1, which is just radical 3. So tangent of 420 is radical 3. And last but not least, cotangent of negative 8 pi over 3. Cotangent means I'm going to put my x value in the numerator divided by my y value. Cancel the 2's. Negative divided by negative is positive. And so let me rearrange something here. So I've got positive 1 over positive radical 3. I'm going to rationalize my denominator, and I end up with radical 3 in the numerator over just 3 in the denominator, and that whole thing is positive. So on the last page, what I've done is I have mixed up all tangent, cotangent, sine, cosine, secant, cosecant. All those problems are mixed up. And so what I want you to do then is wait until I forward the slide and then maybe pause the video and see how much of these problems you can get without me, but then I'll talk through each problem. So like I just said, if I were you, I would pause the video and see how many of these problems you can do without my help, but I will be talking through each one of them. And hopefully I've got my ninja mode set correctly, and so you won't see me zooming in and out. But here we go. Cosine of 300. Anything that's sine or cosine, I'm going to just straight up look at the angle and find the x or y values. So I've found 300 here in the fourth quadrant. Cosine is x values, and so the cosine of 300 is 1/2. Likewise, sine of 5 pi over 6. 5 pi over 6 is here in the second quadrant, and sine is your y values. And so once again, positive 1/2. Tangent of 90, we're going to need to find the x and y values for tangent. And then tangent is going to be sine over cosine or y over x. And so 90 is the positive y-axis. And your x and y values are 0 and 1. So thinking 0, 1, and to do y over x, that's going to be 1 over 0, and as soon as I see 0 in the denominator, that is going to make my tangent of 90 undefined. For 480, before I can find that angle, I'm going to need to subtract 360. And so secant of 480 is going to be equivalent to the secant of 120 degrees. And so I'm going to find my 120 degrees right here in the second quadrant. And secant is 1 over cosine, or the reciprocal of cosine. So cosine is negative 1/2. I'm going to flip the 120 so that it becomes negative 2 over 1. And so secant of 480 is just going to be negative 2. Cotangent of 4 pi over 3, once again, I'm going to need to find both the x and y values. Here's my 4 pi over 3, And so my x and y values are negative 1/2 and negative radical 3 over 2. Cotangent is x over y, and so that becomes negative 1/2 over negative radical 3 over 2. The 2's are the same, so I'm going to cancel them. Now I have to simplify the fraction negative 1 over negative radical 3. Negative divided by negative is positive. Rationalize the denominator, so I get positive radical 3 over just 3. Pi over 4 is right here in the first quadrant. Cosecant is the reciprocal of sine. And so my thinking here is that sine of pi over 4 is radical 2 over 2. But remember that in order to get that, what we did was 1 over radical 2. And it's easier to flip 1 over radical 2. So I'm going to flip that. And I just get positive radical 2. And so the cosecant of pi over 4 is going to be just radical 2. On the other side of the page, 3 pi is actually, hopefully you can tell at this point that 3 pi is going to be a quadrantal angle, but it's still greater than 2 pi, and so you want to find the coterminal angle. So I'm actually going to start by saying 3 pi minus 2 pi is 1 pi. And so 1 pi is over here, the negative x-axis. Secant is the reciprocal of cosine. So I'm going to start with cosine of 3 pi is negative 1. So cos of 3 pi equals negative 1. And then I want to flip that or write 1 over it. So secant is 1 over cosine. So 1 over negative 1 just equals negative 1. Cosecant of 330, I'm going to find 330, and cosecant is the reciprocal of sine. Sine of 330 is negative 1/2, and so sine of 330 is negative 1/2, and then I want to flip that. So negative 1/2 flips and becomes negative 2 over 1. And so cosecant of 330 is just negative 2. (17 pi over 4 is greater than 2 pi, so I'm going to subtract. 17 pi over 4 minus 2 pi. 2 pi is going to become 8 pi over 4. 17 minus 8 is 9. So 9 pi over 4 is still bigger than 2 pi. So 9 pi over 4 minus 8 pi over 4 is 1 pi over 4. And so I'm looking here at this angle right here. And cotangent is your x over your y. So radical 2 over 2, radical 2 over 2. Cotangent becomes radical 2 over 2 divided by radical 2 over 2 again. And anything that's divided by itself equals 1. And so cotangent of 17 pi over 4 is positive 1. Cosine of negative 2 pi over 3, personally, I would just say I know that negative 2 pi over 3 is right here. Or you could add, so you could say negative 2 pi over 3 plus 2 pi is negative 2 pi over 3 plus 6 pi over 3. And that gives you 4 pi over 3. And again, there's your 4 pi over 3. I'm going to erase some of those scribbles in a minute. But basically, we're looking at this x value right here, the negative 1/2. So cosine of negative 2 pi over 3 is negative 1/2. Little technical issue here. Give me a second to erase the scribbles over here. And last but, oh, not last, still having some technical issues. Okay, the negative 405, again, I'm going to need to add 360. So negative 405 plus 360. And I'm going to have to add 360 again. And so negative 405, you can think of it like this, that it went around more than once to here. Or you can say, I know that negative, you can do the first part of your subtraction and say, oh, I know that this is negative 45. Okay. Either way, your tangent then is going to be your y value divided by your x value. So this is radical 2 over 2 and negative radical 2 over 2. Y value divided by x value is just going to be negative 1 because the top and the bottom are the same. So negative 1. And last but not least, sine of 225. Fairly straightforward. Here's your 225. Sine is your y value, so it's going to be negative radical 2 over 2.